All right, so hello everyone. Welcome to this session in which a good friend of mine, John Eros, will be discussing the total solar eclipse of 2017. John is a adjunct faculty at Ivy Tech Community College in Northwest Indiana. He has a bachelor's degree in chemistry from Purdue University and has been focusing uh, much of his professional career on environmental chemistry and has earned the highest level of certification in wastewater treatment and has been working on this for the past 23 years. In his spare time, however, he is a quote unquote amateur astronomer, and I say quote because he's more than just an amateur. He has taken some many photographs of different astronomical events, has worked with the local telescopes in the Northwest Indiana region, and has been teaching at various colleges, most recently Ivy Tech, over 20 years in chemistry and astronomy. And besides all this, he has many other interests and hobbies in different engineering or science aspects. I can keep going on, but I that may be a talk in itself. I knew John from Purdue University when I was going for my undergraduate degree in engineering, and we struck up a friendship when I was there, and he was teaching the astronomy courses. And since then, he and I have been pals, and part of this total solar eclipse project is my fault. So I apologize to John. And
That's okay.
but hopefully you'll see some of the cool things that have come from a very simple question many years ago that has spawned many discussions, many interesting photographs, and many future plans to come. So John, why don't you take us through? If there's any questions from the audience, please use the Q&A. John has been a science educator for many years, so he has some advice if people are interested in this type of stuff, or chemistry or physics or what have you. So take it away, John.
Okay, thank you, Andrew. So welcome to the 2017 total solar eclipse. Andrew and I had discussed this some time ago, which was in 2011. And we were just sitting in the kitchen talking about the measurement for gravitational lensing. And as we mentioned this to each other, we realized that it was about 6 years away in 2017. And so it would be the first time that there was a total solar eclipse since 1979. When the 79 eclipse occurred, I remember seeing it as a youngster, but I didn't remember the corona quite like I saw it now this past time that we did it. I thought a lot about our discussion together and the different things that we had talked about in the measurement of lensing. And so I thought I'd include a picture of me thinking about it here. It looks a lot like myself. And there are times I wonder where that picture of me came from. I think they stole it somewhere. But now let's get back to the eclipse. So for 6 years, up until Friday, August 18th of 2017, we did a lot of work. We had to think about the power consumptions, the configuration, the optics. And the Friday before August 21st, I had gone to work, and we had decided that we were going to go to a location about 4.5 hours away, which is in Southern Illinois, located in the Midwest, just south of Carbondale. And we had chosen 5 weather apps, and we were monitoring the weather for 3 weeks, starting actually on July 31st, all the way through August 18. I had put in 6 hours at work, and Andrew sent me a message and said, have you seen the weather forecast? And I said, well, up until Thursday evening, the weather forecast was the same. And we had made an agreement in the weather apps that if we chose 5 on purpose, an odd number, we wanted to have a majority rule with respect to the number of apps that agreed on the appropriate weather. And we did that from statistics, because in statistics, you need at least 3 in order to consider your options for the best success. And up till Thursday evening, all 5 apps agreed that Casper, Wyoming, and our location south of Carbondale had the same forecast. However, on Friday afternoon, Casper, Wyoming, 3 of the 5 apps conveniently gave Casper a clear forecast. And so now we were kind of under the gun to make a decision. So Andrew and I talked about it quite a bit over the course of about an hour. And we decided that we were going to make our way to Casper. And so the first location change caused us to have a trip of 23 hours away instead of 4.5. 2 of our friends came with us, and they were not too happy with me on this decision. It meant that it was going to be a long weekend of travel, and then we'd have a lot of setup to do. Casper is 1,200-mile drive west in Wyoming. And because I had worked, I wasn't able to take half the day off or the full day off. So I had to go home and load the car. So I had to work a full 8 hours. I went home and loaded the car for 8 hours and then picked my friend up at midnight. And then Andrew had his friend from Southern Indiana, and we met at the I-80 truck stop several hours later. As you're traveling west, the altitude increases as you approach the Continental Divide, passes part of the, or what is the Rocky Mountains. And so we were going to be in elevation about a mile higher, about 4.5 miles higher than we are here. And that's not good for gas mileage. So if you put a heavy load, if you know in physics or any type of science, if you look at the mass and the energy it takes to move that mass, the more mass you have, the more energy it requires. So we're also going against the jet stream, which didn't help. So here's a look at the exaggerated path of totality between Casper, Wyoming, and a place called Vienna, Illinois, just south of Carbondale. And you can see where home is for us, or at least for me anyway. So we left on Friday evening, well, really early Saturday morning, right around midnight, but just a little bit before that. That gave us 58 hours up until the time of the eclipse. And initially, when my friend Dave and I had gotten into the car, he had made the comment, well, we got plenty of time and we'll be okay. Turns out that we kind of pushed the envelope there. The payload was heavier than the vehicle could handle. And when I returned, I needed new shocks. About 3 days before we left, if you recall on the news, they announced fires in Montana. And in doing photography and trying to capture light of stars through the atmosphere, any type of additional constituents such as air pollution or humidity or moisture affects something that we call air mass. And the heavier the air mass gets, the harder it becomes to capture light through the atmosphere and also to account for the distortion. And so I had this thought that we would not be able to see anything and wasn't quite sure why we were driving out. We met at the I-80 truck stop, and someone said, whose idea was this? I'm not going to mention who it was, but I think he introduced me today. So once we got to Casper, we didn't know that we were going to need vibration suppression. Our spot located in the East RV Park failed to mention that there were a set of train tracks less than 20 feet from us. Now, if you know anything about trains, especially the ones out west, they haul a tremendous amount of cargo, and generally they have anywhere from 4 to 5 engines, some cases 6. And these trains create a tremendous amount of vibration that gets transmitted through the ground. And if you're within just a few anywhere from 10 to 20 feet, you can feel your body shake as the trains pass by. And so when you're trying to capture an image on a camera, and we're interested in a point of light on a pixel that's 3.9 nanometers, or about the same as 3.9 times 10 to the minus 9 meters. That's a very, very small area. And any type of vibration at all will cause a blurred image and affect our calculation. So my natural question initially was, how often do the trains go by? And the owner told me every hour on the hour, and they also pass by in between, which means in a 3.5-hour astronomical event, we could have as many as 9 or 10 trains. So after asking this question, I was feeling just like this, and I had no idea what to expect. And the more I thought about it, I really had wished they had mentioned to us about the trains. And so then I was feeling sort of like this. And we were trying to come up with a real-time solution 1,200 miles from home. So we got there on Saturday night and we set up camp and got a couple hours sleep. On Sunday, we woke up and Andrew and I decided around noon it would probably be a good time to start setting up the mount and getting things together. So 24 hours prior to the eclipse, which is just about 10:30 on Sunday, it takes three of us, Andrew, Dave, and myself, 7.5 hours to accomplish the alignment. And that sounds like an awfully long time, and it was. We went to make an adjustment on the mount, and Casper is a little bit over 40 degrees, and it's actually just shy of 43 degrees in latitude. And so it's about 42 degrees and somewhere between 58 and 59 minutes. Because of that, the manufacturer for the mount that I had, the mount handles a very heavy payload, about 150 pounds of optics and camera gear. In order to maintain that mass, they had put in presets into the mount. And so we start dialing the mount to 43 degrees and the mount locks up at 40. And if you know anything about astronomy or tracking or trying to do imaging, you really want to have perfect alignment with Polaris so that the Earth actually turns one of the axes for you, and it makes the tracking of the object through the sky much easier. In doing so, we loosened the screws on the mount and I heard a metal plate fall. We hear this ka-chink, sort of very distinct, loud sound. And I looked both at Dave and Andrew and I said, please tell me you guys didn't hear me. And they actually did. Okay, I'll address, so for students who would like to admit or get into Purdue University,
you can wait till the end to talk. There'll be some time to answer.
Okay, okay. I'll address that at the end then, if that's okay. All right. So this mount, we have the plate that falls. It's a pressure plate that helps us put the gear on. And as the three of us are working on this, I'm sitting Indian style under the mount. Dave's trying to hold the mount in place, and we didn't realize it, but there's some mass actually from the mount itself and where the polar axis is. And so Andrew actually had to hold the polar axis up while Dave tried to get the screws in. And we find that the meridian is the imaginary line through zenith, which is the point directly above you in the sky. It passes from due north to due south, wherever you are on the globe. And so when you do a polar alignment on the mount, with respect to the meridian, you have an east side and a west side. And so there's a pressure plate on the east side. As it turns out, there's also a pressure plate on the west side. And so each plate took us about 3 hours to get reset to the new preset. The manufacturer didn't mention this, and 1,200 miles west in Casper, Wyoming is not the time to discover this. So at this point, I'm really thinking hard because now we have to make sure that we get all of these things worked out. And during the time that the event is taking place is really not the time to have problems. If you think about this and you're a person from the outside, you may think that rather than me thinking hard, I probably was a little bit upset. And it turns out that, when I think back on it, probably just a little bit. But again, we didn't know at the time that there were presets, and so that's okay. If you notice these pictures of me, though, you'll notice my forehead's really shiny. So after we get the mount set up in the 8 hours, it's just about 7:30, 8 o'clock at night on Sunday, and Andrew's sitting there on his laptop checking the weather, and he says, John, we got a storm rolling in. The picture you're about to see here shortly is a setup to measure gravitational lensing. And an idea that we had was to try to quantify the distance out from the solar disk that lensing actually occurs. And so we decided to use several focal lengths. Well, it turns out that those cameras take about 45 minutes to set up. With a storm rolling in at 15 minutes, there is absolutely no way we can undo this. So another consideration we had was we had no idea where we would be on the path of totality, or if even if we were able to get this spot in Casper, I had no idea if we had bathroom facilities, if we would have electricity. And so all of these things we had to account for. It turns out that Andrew and his friend drove out in a separate car because I had brought 2 batteries with me. Each battery weighs about 250 pounds and is the equivalent of 8 car batteries connected in parallel. It means each battery of the 2 in my car provide just shy of about 3,000 watts of power apiece. And so with 2 batteries, we drove to Casper with over 6,000 watts of power, stored potential energy sitting in my back seat. Because the batteries weigh 250 pounds, they took the place of 2 people. And that's why Andrew and his friend had to drive separately. In addition to the power requirement, not knowing if we'd have bathroom facilities, we decided to bring a portable outhouse. With that portable outhouse came a very large box of garbage bags and a significantly large package of toilet paper. And you'll understand this in just a moment. So with respect to the storm, the only thing we had were the garbage bags and some duct tape. And so we decided to tape garbage bags together over the optics and weather the storm and see what happens. It turns out the storm didn't last very long. It was a little bit, maybe 45 minutes to an hour, but now I'm feeling with the change in the weather that the success here inside, I was probably crying just a little bit. We had come across so many different hurdles. Then the storm passes, about an hour and 40 minutes or so, something like that. And now it's about 10:30 on Sunday night. We go to align the platform and balance it, and the platform will not balance. And as it turns out, I had gotten so caught up in making this relativity measurement that I forgot about the counterweight. And so luckily for us, at the East RV Park, they're a long-term stay facility for people who travel and work. And so it turns out that there was a weightlifter who had been there, and he was there for maybe about a year and a half. And when he left his weight set behind. As we were working, the owner drove past and asked if we wanted to use any of the weights. I asked him if we could, and if he had left any plate weights that would allow us to put them on the mount. Because of this, I had to cut apart the mount with a Swiss Army knife branch cutter. And I had built the platform out of wood in the idea that if we ran into too many problems, we might have to modify the mount. However, I did not have any battery tools with me, nor did I have a saw. So it took me 4 hours to do this by hand with a Swiss Army knife. And you're going to see the modification here in just a moment. But when I got done cutting the mount apart, my hand hurt so bad, I was crying. It turns out Dave, Andrew, and Jimmy were all asleep, and so they didn't get to witness my tears. So there's now 6 hours left. It's about 4:30 in the morning on Monday. And I decided to proceed with the alignment. At some point throughout the night, after the 4 hours of cutting it apart, we were able to get the balance. And in recent years, I've been on blood pressure medication. And so as I'm out there working, I'm sweating, and this is definitely not good for my blood pressure. And here's an example of what happens when my blood pressure goes awry. And so as you can tell that I'm on the video here, I actually survived it. So that's good. 3 hours prior to the eclipse, after getting everything aligned and set up, I had an unfortunate incident in which I basically fell asleep in the chair next to the mount. And Dave and Andrew, and I'm not even sure if Jimmy was in on it, but they thought it'd be funny to take a picture of me. Very quickly, I'd like to point out here now, you can see the camera lens that is on top, which is one of the 4 remaining that would have been for attempting to measure the lensing effect. We have 2 video that we're supposed to run. One was a visual light filter and one was a hydrogen alpha filter. And you can also see the counterweight here, and you can even see the plate weights from the dumbbell or the weightlifter had left. And you can see what the mount looks like. This is a German equatorial mount, and this is your polar axis that aligns with Polaris. And so the Earth does some of the turning for you, and all you have to do is really adjust your altitude. And the last thing I'd like to call your attention to in this image is you'll notice the 3 rolls of toilet paper. With the vibration from the train and bringing the portable outhouse with us, we decided to put 3 rolls of toilet paper underneath the mount. Now this mount, even just with the 1 camera lens and these 2 other telescopes that were to take video, this mount right now weighs just shy of about 500 pounds. With the other cameras on, it's even more than that. And what we really weren't sure was, would the toilet paper provide enough vibration absorption that we could get some clear images out? And so at this point, it's early in the morning. And so let's take a look at the scientific data, the latitude, longitude. So this is Casper, Wyoming, and you'll see Casper is 42 degrees, 51 minutes, and 59 seconds, and also 5,118 feet, just 2 feet shy of a mile in altitude. This is what the mount originally looked like. You can see we have multiple cameras on top, different lens sizes, meaning different focal lengths, and lengths that would allow us to potentially measure the lensing effect as it occurred during totality. Then we have the 2 video. This picture here, you can see the counterweight does not have the plate weights from the weightlifter, what was provided by the RV park. And clearly, when I look at this picture now, I realize I got too focused on trying to measure the lensing effect, and we completely forgot about it. When you look at the mass and the volume and size that we have here, we see that we have a much greater amount with a pivot point and a very small counterweight. So in science, whenever you're considering an experiment, make sure you consider all aspects and do not forget about any variables. Okay, this is another image on the backside. You'll notice that I aligned all of the cable releases. You'll notice that each camera battery pack has a label. You notice that each camera has a label on top. In addition to that, each camera card is labeled. And so I know exactly what camera goes with exactly what lens and onto exactly what camera card for the data. Because if we were successful, we would have to be able to access a pixel on each camera in order to do the calculation. And we cannot mix up cameras because if there's a difference in pixel size, it could alter or vary the calculation. You also notice that each cable release has a label on it. And that way, in case any one of these fails, we know exactly which one it was and we could replace it. I had these all put in the same place because during totality, we only had 2 minutes and 30 seconds, and I had to get as many images in as possible. As it turns out, we pulled in about 800 images in 2.5 minutes off of 12 cameras and 3 laptops. However, 2 cameras and 2 laptops did fail during the eclipse, and that's because the body's overheated. Okay, the owners of the RV park also provided us with some caution tape when they saw our setup. They thought we were from NASA, and we all kind of laughed and said, nah, just a bunch of avid scientists. If many of you are familiar with the movie The Matrix, this here is Agent Smith. But not really Agent Smith from The Matrix. That's just my friend Dave, so sorry about that. And this here is Andrew back in the day. And you can see here the following morning, all of our cameras have the solar filters on the front to protect the eyes up until totality. And you can see that we've also moved the additional cameras that were on top to individual tripods. And so we had thought about all of these things. We had come up with contingency plans, and I hope you are about to enjoy this. Remember that all of these images come from a mount that's sitting on 3 rolls of toilet paper. So you can see here just a few seconds after first contact, you'll see some spots on the surface of the sun. Those are sunspots on that day. We had 2 groupings, a nice set of 4 here and an additional pair on the opposite side. As the images progress, it turns out that we also did a calculation for universal time, the time of the event based from Greenwich Mean Time or the prime meridian, and then accounted for the local time, meaning that you have to add or subtract based on your time zone. What we did here was we took into account the entire time of the event, and knowing the entire time of the event, we decided that we wanted to get a certain number of images on either side for a complete view of the eclipse itself. And so we had taken that time, divided by the number of images that we wanted. And so if you have your total time and your number of images, we can determine the time between images. And these are individual stages of the eclipse. And so you'll see shortly how the symmetry happens when you set a timer to the appropriate time. This is just a few seconds before totality, and you see the diamond ring there very nicely. This is the last visual filter we took through a hydrogen alpha. You can see on the lower left side, we have a little bit of activity there in the corona. And then this is the natural or the visible light corona, scattered light corona. It's extremely bright. And again, as I mentioned, it's brighter than I recall it from 1979. As the process progresses of the shadowing of the moon, we have the reverse diamond ring. And then as that light gets scattered over a surface area, the brightening, or what we call that is also a lensing effect. And then the light diminishes a little bit until we get back to our normal surface that we see here through the solar filters. And again, remember that what you're seeing here, this entire event for totality, the totality portion was only 2 minutes and 30 seconds, but the entire event was about just shy of 3.5 hours. And so all of these images were taken over the course of 3.5 hours. You'll also notice a difference in the shading of some of these images, and that has to do with air mass and where the sun is located in the sky. In the last 15 or 20 minutes in Casper, we still got some clouds, but you can see some of the sunspots even through the clouds there. This image was taken off of the hydrogen alpha scope, and it was through the clouds and kind of looked like the moon and the sun were on fire. And so this is what a solar prominence through the hydrogen alpha scope looks like. And we can see the symmetry on either side. You're going to see some really nice symmetry here with the natural light corona over the 3.5 hour event. And the symmetry itself was defined by our calculation of the duration divided by the number of images that we wanted. And so I set a timer on my phone, and every time Chewbacca roared, the three of us would scurry about taking pictures through as many cameras as we could. Another thing I do in photography is called HDR photography, which stands for high dynamic range. And you'll see that the shape of the corona, the style of it changes just a little bit here. After the event was over, many people were headed back through normal pathways on the highway, and it was a trip 3 hours away to Denver was taking 14 hours. So my friend Dave and I decided to head north towards Devil's Tower, which was the opposite direction everyone else was traveling. And they say that during a total eclipse, the sky gets very dark. So these are artistic renditions of what the sky might look like. It turns out the sky doesn't get anywhere near that dark. It gets the equivalent of about an hour just before sunset. So it looks sort of like twilight. And now let's look at the images individually. Oftentimes I take the stages, and I also talk to art classes about things. If you know the science and digital imaging, if you know the science, you can create artwork from that science. And here we see, again, really nice symmetry on either side of totality. And then I chose colors from different stages within the eclipse to create a border that creates artwork from the eclipse and an appreciation for the event in its entirety. My sister-in-law asked if I could put the diamond ring on both sides before and after of a natural light corona, and so I did that. And then I came up with the idea of actually putting the corona behind each one and sort of showing some more symmetry artistically. You'll see a few more series here. In this series, we decided not to incorporate the diamond ring so we could see the symmetry on either side without the glare from the lensing effect of the surface at the diamond ring on either side. And then you'll see a series of borders that were chosen, again, from stages within the eclipse. Those are not arbitrary colors. I actually took a sample from each side of what we actually captured, and that defined the color of the borders. And in art, oftentimes you choose different colors. You might wonder why you're looking at different color borders here. And that's to draw your eye across the artwork and to give the artwork some depth. It turns out here we have a nice red center. And so in the next image, I decided to go with the red border taken from the activity that we saw just at the very edge of the corona there. And then on the other side, your eye maybe cannot see it really well, but there's a light effect just on the opposite side, and that color turned out to be magenta. And so I decided to border it with these two colors here. Now, I mentioned that we go on to Casper to measure the lensing effect. And this is the natural light corona as you would see it. And I mentioned that I do high dynamic range. So high dynamic range accounts for overexposure and underexposure. And this is a look at the corona through high dynamic range. And the idea here was that through overexposure and underexposure, we might be able to pull in some stars from behind the corona. In looking for those stars in to color some of it, hoping that we might pop a pixel and see if we've captured light from a star. And you'll notice that we captured two things that look like the iris of what's called a cat's eye. And so at the center here, this is called a cat's eye, and it's really just overexposure that bleeds over on pixels. And in science, we call that RBI, which is residual bulk image. The phenomenon occurs because of the moon passing in front of the sun. And so if our eyes could resolve both natural light and infrared, we would see the coronal activity just outside the surface. This is a physical impossibility. I did this artistically. This is the blood moon of a lunar eclipse with the corona of a solar eclipse, and neither the sun nor the moon can be in both places at the same time. Okay, so this is a look at the inner and outer corona. We can see the inner ring here where it's very bright. And then there's a phenomenon called the halo of the moon, the halo of the sun. It turns out we captured the halo of the eclipse, and this happens to be a planet that we captured. Not necessarily, ancient people would consider it a star, but it's really a planet based on what we know on star charts. So here's a look at the diamond ring. This is a natural light image, and what we're going to see now is an HDR image of the diamond ring taken over just less than a minute, but we can actually see a shift in the solar disk just over 30 to 40 seconds. Okay, so all of the images that you saw just here recently, when we went to Castor, Wyoming, we had not intended to capture a single one of those images. We had gone for something completely different. But due to technology, as we were driving back, Andrew's friend Jimmy had taken some pictures, and we had made a phone call, and we're both coming back down I-80 doing about 90 miles an hour, which is a little over the speed limit, so you're not supposed to do that, but we were tired and wanted to get home. It turns out that we set up a drop box. So here's where technology really works well. We're traveling down the expressway, and let's just say for all practical purposes, we were doing 65, which is 5 miles under the speed limit. If you think about doing 65 miles an hour, setting up a drop box off 2 laptops between 2 vehicles and sharing gigabytes of data from the eclipse and looking at images in real time, it was absolutely a fantastic experience, especially the drive home. I have a quote here. I'd like you to think about this quote and see if you know who gave this quote in history. It's a famous quote given by a famous person. And so the quote states, "Nature shows us only the tail of the lion, but there is no doubt in my mind that the lion belongs with it, even if he cannot reveal to himself to the eye all at once because of its huge dimension." This quote was given by Albert Einstein when he predicted relativity. And so we had gone to Castor, Wyoming to make the gravitational lensing measurement in the hopes that we would get a star. In the images that we processed so far, if you think back to what I just showed more recently, the corona is black, or excuse me, the solar disk is black, and the corona is very bright. Through imaging software, I can make the solar disk black. Excuse me, I can make the solar disk white, and I can make the corona black or dark, sort of grayed out. After we run some software, we can actually cancel out the noise. And if you see this pixel right here, we believe at the time that we thought we had captured a star. It's possible that it still could be a star on the celestial sphere, meaning part of the night sky. The problem is with the lensing effect and the calculation. It is effect predicted, and in order to calculate it, you must have the position or the relative positions of 2 stars relative to the center of the solar disk. And since we only have 1 star, we only have half of what we need for the calculation. This was attempted back in 1919, and that was, my understanding is it was the 3rd attempt by Sir Arthur Eddington and Sir Freeman Dyson, along with in an attempt to solidify general relativity. Because of World War I, they had gotten delayed at the border, their equipment had gotten confiscated, and so they were on several attempts. And that means that for them, they actually had a couple of failures as well before they had the success. For us, in a way, it's a success because we have a point of light behind the corona. But in fact, for us, it's actually a little bit of a failure, mainly because we weren't able to capture the 2 stars. And that's okay, because everything is a learning experience. And so my students, I recommend a book, if you find it, called Galileo's Commandment. And it's a book about the successes in science, but it's the successes because of the failures and what we learn. It turns out that even though this was a failure, it was still a success because we learned something new that I hadn't remembered about the intensity of the corona. I learned that I need to considerably make a deep consideration on our counterweight and how we're going to do the next eclipse. So what could the potential success from this be? In 2024, there will be another total solar eclipse. Andrew and I have already discussed, and I've started working on our next array for the 2024 eclipse. And I hope that when 2024 comes, we'll have something even more fantastic to show you than I did here today. It turns out that Andrew's friend Jimmy, while we were there working, kind of disappeared during the eclipse, and we were sort of joking about what happened to him, and we weren't sure where he was at. Oftentimes in science, we run experiments and we look at data, and the data is presented, but we never really get to see ourselves working. It turns out that Jimmy was actually going around and taking pictures of us working. And so I have these images to share with you today. Because we were able to capture a star behind the corona, remember that that mount was resting on 3 rolls of toilet paper. There used to be a commercial about Charmin toilet paper, and they asked, can you squeeze the Charmin? We were able to capture a star, 3.9 nanometers, on the size of a pixel of a camera. If someone asks you if you can squeeze the Charmin, you can just give them a wink and a nod. The Charmin did absorb the vibration from the trains and did allow us these images to share with you. And so now let's take a look at us working. This is what Casper looked like on the day of the event. Many of the people that had been gathered around were trying to get behind the tape. Here's Andrew, myself, and Dave working. I'm about to show you in the next image here what one of the power sources looks like, so pay careful attention to the battery. You'll see the battery here. This is a 250-pound battery with a power distribution center that I designed and Dave helped me build. We actually built 2 of them to handle the 6,000 watts of stored power that we were going to use for the eclipse. Here's a look at the mount. You'll see that I even put some washers at the top to counterbalance the lens on top. And then just some more images. This is my friend Mark from Houston, Texas. He actually shared or split his spot with us in the RV park. And if the owners of the RV park hadn't let him do that, we would have had to gone to Southern Illinois that day. And on that day, it was actually cloudy. Just a picture of us working and double checking time. That's Andrew there, making sure that we were on point for our images. And also, of course, we're waiting for the roar of Chewbacca. And so it was really neat to see that Jimmy had captured these images of us working. And there's another image of my friend Mark, and also a friend that we made from Denmark. His name was Leif. Him and his wife were both there observing the eclipse. And this is a picture at the one moment that Andrew and I thought we had really captured just about everything. You can see here, once again, the toilet paper that the mount sets on, and the toilet paper did absorb the vibration. And so a project like this takes a tremendous amount of work. My wife, Becky, puts up with all of my nonsense. And so when Andrew mentioned about mentioning projects and that, him and I from Becky are not allowed to discuss projects anymore, but we're still working for 2024, so that's okay. My mother-in-law, Becky's mom, Joanne, let me use her living room for 3 months as a labeling facility to label all of the equipment and test the equipment, make sure everything was working before we left. My brother-in-law and sister-in-law helped us with our way out to Casper, so that was nice. And then, of course, a special thanks to Andrew for suggesting this project, sitting in my kitchen as we were just sitting around chatting as we normally do when he's visiting. My friend Dave helps me build and test the equipment. And so that's a huge help for me because it allows me to think about other things more, say, on the theoretical side. A special thanks to the owners of the East RV Park. The night before the eclipse, they were charging $1,000 a night. When we arrived, I asked them what they wanted for the fee to be there. And they told us that they would simply charge the $35 normal per night for the 3 days. And so it really cost us a fraction. And of course, the four of us split that, so it was even less. My friend Mark from Houston, Texas, him and I have done astronomy out west together for the last 20 years, and it was really kind of him to share his spot with us. Jimmy Seward is Andrew's friend. He took all of the live action shots that showed us working. And so if it weren't for him doing that, I wouldn't have had those to share with you. A special thank you to my friend Jim, who actually reserved our other site in Vienna, Illinois. And it was originally our first site that we were going to travel to until Casper got the clear forecast. Special thank you to my friend Larry Kaplan and a camera store that I have visited over the course of my life. Really, I've visited that camera store for the last 37 years. Sadly, the camera store closed and he's no longer in business, but it makes it a little bit tough. Special thanks to my friend Vaughn. He helped me learn some things about film photography, and through that knowledge that I learned, I was able to transition to digital and build the mount that you saw there. And then of course, mom and dad usually always support us. And so a special thanks to my mom and dad who have always supported my pursuit of science and the endeavors that I've done. That's my thank you to the living. Unfortunately, I've had a lot of friends over the years who have passed away here recently. All of these people have contributed in some way, shape, or form to my knowledge in photography, knowledge in astronomy, and have helped me along the way. And so a special thanks to them. Becky, when we were shopping, Andrew and I would be texting or calling each other, and she would say, let me guess, oh, it must be the project. And so this became the project for the eclipse of 2017. And I guess the project we're working on now is the project 2.0 for the year 2024. Generally, if we're not on a webinar, there's some music that accompanies this, but I'm not able to broadcast that music through this way, but I will say this. My friends and I that have traveled out west for the last 25 years try to support the Native American. And we've had some of the greatest experiences with astronomical phenomena in slot canyons on the summer solstice, which is June 21st, when the Earth is tilted its farthest towards the sun. So many degrees, 23.5 degrees, and it puts the sun just shy of about 15 or so degrees to zenith, and the light inside the slot canyons is most incredible. One of the greatest experiences in my life was having a Navajo Indian as a tour guide, and he played something called the recorder. It's a native flute made of wood. And as a youngster, I played music, and music, as you know, comes with beats and counts, and you have to keep things in your mind as you're playing. The sound from playing music when I was a kid, I played in concert halls, and my wife and I attend concerts and stage plays, and I know what sound is like. And the sound that I heard in the slot canyon that day was like sound I've never heard before. And so my only regret today is that I wasn't able to share the sound with you, but there is a project between professional musicians and the Native American. It's called Anima. And the song that I had chosen during the stages of the eclipse would have been from an album called Grand Circle. And the song itself was Mountain of the Sun. And if I could have finished with the music for the slides, it would have been George Harrison's Here Comes the Sun, which is appropriate for a solar eclipse. So I hope you enjoyed the images from our work here. Know again that those images were really our pursuit of the lensing effect. And that means that Andrew and I are going to be working here in 2024 to accomplish the goal of the calculation. So not only in 2024 do I hope to have two other phenomena for you that we weren't able to capture. Remember that I mentioned two of the cameras sort of shut down because they had overheated. And because of that, two of our video we were not able to, capture this time. So in 2024, we hope to do that. And I also hope to have the lensing calculation for you.
All right, John, thank you very much. I always enjoy seeing these images from all of our hard work, and it's pretty impressive the amount of knowledge you gain over the years and how you apply it to very simple technical challenges. So if you have questions, please use the Q&A. We have two questions now from Andreas. The first is regarding some advice you can give to students that want to be admitted or to enter Purdue. And perhaps you can kind of tag along that question with, the importance of kind of your science background and how you've applied it in every day.
So the best suggestion I have to students as you prepare for college, make sure you study hard. Do not skimp on the time. And you'll notice that I put in a thank you to people who came before me and friends that I've contributed to everything. In life, it is a learning experience. And when older people who've gone before you make a suggestion, make sure that you take that advice to heart. And if you do that and you work really hard at things, don't let a problem that you can't solve get you down. Keep working on it until you solve it. It's what all scientists do. It is actually the endeavor of science to continue digging deeper and deeper. I was just listening recently to Astro Talk with Neil deGrasse Tyson, and they talk about measuring gravity waves. And if you think about light measured as a photon or a wave, because we measured gravity waves, they're talking about a graviton, hopefully would be a particle that could potentially be measured and come out of the measurement of LIGO, which measured gravity waves. It is our pursuit continually in science. And so as a student, you want to learn as much as you can, read as much as you can, and continue solving problems and doing the best possible. The other thing I'm going to tell you is, even if for some reason you're not the number one person, I was not the number one person in my student class in high school. That doesn't mean that you can't accomplish great things. So never give up. Always give it your all and try your best. The best thing you can do is talk to your counselors, see what they tell you, listen to your teachers. Many of the people that were in the memoriam that I had are teachers who have gone before me, some relatives, some friends, but some were teachers, and I listened to what they told me, and I never gave up. And even though I wasn't number one, or I wasn't accepted to the greatest place, I think we've been able to accomplish some pretty interesting things here. And that means that you can accomplish some great things as well. So pay attention to your GPA and never stop learning or trying hard. I see the second question here for
Yeah, so thanks, John. A question from Andres again, and maybe others would be interested. Would you be willing to share your contact information, such as email, so students can get in contact with you?
Yes, absolutely. Let's see here. Maybe
There
we
is a
can
chat function to panelists and
there we are. So there is my name and email address.
If you don't mind, I'm also going to put it for the panelists and attendees.
Okay.
Everyone can see.
Okay, so there's my name and email address. The students that I teach here, even if they've had a class before me or have not been in class with me for a while, they're always welcome to come back and see the new and interesting things I've done. I even invite my students to come out with their telescopes or with their camera gear if they're interested in learning how to do this. And so if you're at all interested in learning how, please don't hesitate to send me an email. I'm happy to answer anything. The other thing I will say today is that there are some pretty fantastic images. And if you think you liked an image particularly, you can go back to an image. And if you send me an email, I'll be glad to print it for you and mail it to you.
Thank you, John. I know we're coming near the end, but maybe just one last question. Advice maybe to students and to professionals even in this simple, quote unquote, simple project. You experience many challenges along the way and problem solving of different areas. So you, as I mentioned, you were trained in chemistry, but you have to solve a lot of problems in various different things: engineering, electrical, circuit stuff, so on and so forth. When you are approached with a problem maybe just a little bit of advice of how you can kind of attack that problem to give it a solution and kind of how to approach your clients.
That's actually a great question, and the best answer I have for that is this, and it gets back to exactly what I mentioned. All of us are students in life. We all have experiences, and approaching a problem, never be afraid to think outside the box. Thinking about things in different fashions, as you know, you and I have great discussions at length on looking at a problem, and we approach a problem and we say, okay, what happens if this occurs? Then what do we do? And we look at as many scenarios as we can configure and as many solutions as we can come up with. And I think as students learn things, we are creatures of experience, and those experiences help us learn, and it shapes our method and level of thinking. And whenever I look at a single problem, I always try to think of multiple ways to solve it. And the more ways you have to solve a problem, the better you become at problem solving itself. And it doesn't matter your background. The more background you have in other things, you find that there is overlap in topic and overlap in theory, and it makes us better problem solvers. And the better problem solvers we become, the more we can advance science and technology for the next group.
Thank you, John. Yeah, so I think we should be wrapping up here so the next speaker can start getting prepared. I just want to say thank you again for sharing this experience with us. You have definitely shown that there's not a one topic science. There's some problem you want answered, various ways to approach it, many different things you can call on from things you've learned over the years, and to also not ignore the fact that science really can give some deeper appreciation in connection to art. So I really appreciate that. Thank you very much, John. And yes, your contact information is available. Just parroting what you said before, please contact John if you are interested in any of the photos or want to talk science. John can talk for days on science. I know personally. Thank you very much.
Thank you. It's been a pleasure.